Somewhere in the last 6 weeks, mathematics broke. Not the subject itself, the way it's practiced. Problems that survived 30 years, 50 years, almost a century of the smartest people on Earth throwing themselves at them, started falling. Not one, not two. A cluster of them, in the same summer, some of them a day apart. And the thing doing the falling wasn't a new theorem or a new genius. It was AI models, turned loose on open problems, and mathematicians just watching. Terence Tao, arguably the most respected living mathematician, a Fields medalist, someone who does not exaggerate for clicks, has spent this summer writing not about a breakthrough, but about a crisis. Not a crisis in the math, a crisis in the practice. Who gets credit? What counts as a proof? Whether the field's entire verification system was built for a world where results arrive 1 a year, not 5 in 5 weeks. Let's start with the one that actually broke the internet. The Jacobian conjecture had been open since 1939, 87 years. It's a deceptively simple question in algebraic geometry. If a certain kind of polynomial map looks locally invertible everywhere, is it globally invertible? Simple to state, brutal to prove. It's been called one of the hardest open problems of the 21st century, and generations of mathematicians built entire careers just chipping at its edges. On July 21, 2026, Levent Alpöge, a mathematician working with Anthropic, posted a 216-character counterexample. Not a sketch, not a plan for future work. An actual, checkable disproof, 3 polynomials, short enough to fit in a tweet, that any working mathematician could verify by hand in an afternoon. He built it working with Claude Fable, Anthropic's frontier model, using the AI to explore the search space and check calculations a human would need weeks to grind through by hand. Terence Tao himself later published a full technical breakdown of the construction, and even he described it as looking, in his words, like a miracle of cancellation. Years later, he's still working to explain geometrically why it works at all. Sit with that for a second. A problem that outlasted 8 decades of the best mathematicians alive fell in what sounds, from the outside, like an afternoon. And it wasn't alone for long. The very next day, July 22nd, a researcher named Dmitry Riemann, a math Olympiad veteran, disproved a completely different 30-year-old conjecture, in graph theory this time. The Dinitz-Garg-Goemans conjecture concerned network flows, whether you could always reroute a fractional shipment into an unsplit one without blowing past a certain cost penalty. Riemann, working with GPT 5.6 Pro, needed only a handful of short prompts to land on a small graph that broke the assumption completely, a fractional flow that cost 58, against an unsplittable version that couldn't come in under 60, no matter how the capacity limits were bent. 30 years of graph theorists had assumed that gap couldn't exist. It took an afternoon chat log to prove them wrong. 2 conjectures, 2 different fields, 2 different AI labs, 1 day apart. If this were happening in isolation, you could call it a fluke. It isn't isolated. Because less than 2 weeks later, OpenAI dropped something bigger. Their upcoming model, Astra, didn't disprove 1 open problem. It made verified progress on 10 of them at once, across mathematics and theoretical computer science. New bounds on high-dimensional sphere packing, closing in on a threshold mathematicians have circled since the 1970s. A disproof of Connes rigidity conjecture, a decades-old question about whether certain mathematical groups are uniquely defined by their deeper algebraic structure. Progress on arithmetic circuit complexity, on quantum game theory, on a famous Erdos problem about Ramsey numbers that had resisted improvement for years. OpenAI says the compute cost for the whole run was around $2,000. And critically, they said the plain part out loud, human mathematicians reviewed and take responsibility for the results because, quote, claiming human authorship for a proof generated entirely by an AI system would misrepresent the work. That line matters. Write it down. We'll come back to it. Now here's the one with Anthropic's name directly on it, so we're going to slow down and get this exactly right, because sensational but wrong claims about frontier labs are exactly the kind of thing that gets repeated and then debunked a week later, and we're not doing that here. The headline going around is that an unreleased Anthropic model made a major breakthrough on the Riemann hypothesis. That headline is not quite true, and the true version is honestly more interesting than the exaggerated one. The Riemann hypothesis, 167 years old, arguably the single most important unsolved problem in mathematics, worth $1 million Millennium Prize, was not solved. Anthropic says so themselves, in plain language. They don't expect the techniques involved will lead to actually proving it. What happened instead is real, and it's still remarkable. An Anthropic staffer named Jared Sumner, better known outside math circles as the creator of the Bun JavaScript runtime, and by his own admission not a professional mathematician, spent 54 hours across an unreleased internal research version of Claude, coordinating roughly 60 subagents through 2,400 shell commands and 31 million tokens of output. The result was a real, lean verified improvement to a related bound. The known fraction of the hypothesis's zeros that provably sit where the hypothesis predicts moved from just over 41% to just over 67%. That's not the Riemann hypothesis solved. It's a genuine, formally checked step forward on a problem that's barely moved in decades, achieved, notably by someone who wasn't a mathematician, mostly by encouraging the model to keep trying different angles instead of doing any of the math himself. So here's the actual pattern underneath all four of these stories, and it's the part worth remembering after you've forgotten every proper noun in this video. In every single case, the human didn't do the math. The human posed the problem, ran the search, and, this is the part that never gets skipped, no matter how the headlines read, verified the result afterward, formally, often with a proof assistant like Lean, before anyone called it real. Alpöge checked the counterexample by hand. Anthropic had two in-house mathematicians formalize the Riemann-adjacent bound. OpenAI explicitly took ownership of correctness rather than crediting Astra as an author. The AI is doing something closer to an infinitely patient, infinitely fast search through possibility space than it is doing understanding, in any human sense. It doesn't know why the Jacobian counterexample works. Dow is still writing pages trying to explain that part. And to be fair to the skeptics, there's a real trade-off buried in all of this that the hype cycle keeps skipping past. None of these results happened for free. Anthropic's Riemann run alone burned through 60 coordinated subagents and tens of millions of tokens for one improved bound, not a solved problem. That's not a knock on the result. It's a reminder that AI solved it is doing a lot of quiet work in these headlines, when the honest version is closer to AI searched an enormous space fast enough that a human could finally see the answer, and then a human confirmed it was real. Which is exactly the tension that pushed 16 mathematicians from universities across 4 countries to publish something called the Leiden Declaration on June 2, 2026, weeks before any of this summer's results even landed. They weren't reacting to one scandal. They were reacting to the shape of what was coming. The declaration argues that AI is a legitimate and powerful tool for mathematics, full stop. Nobody signing it is a Luddite. But it draws a hard line. Mathematicians, not models, remain responsible for authorship, for originality, and for the correctness of what gets published under their name. It calls out a real risk that research priorities quietly drift toward whatever problems happen to be AI-friendly, rather than whatever problems actually matter. It flags that models routinely fail to credit the human work they're built on top of. And it asks for something almost boringly reasonable. Disclose when AI was used, keep peer review in place, and fund academic researchers well enough that verifying frontier lab claims doesn't become a privilege only the labs themselves can afford. That's the real story of this summer. Not that mathematics is being replaced. Every single one of these results still needed a human to pose the right question, and another human, or a formal proof assistant, to confirm the answer was real before anyone trusted it. What's actually breaking is the pace. A field that historically measured progress in years just watched 4 separate long-standing problems move in about 6 weeks across 2 different AI labs, verified by real mathematicians who are now openly asking whether their entire system for building trust in a result was built for a speed this fast. Terence Tao's answer isn't panic. It's a call to rebuild the scaffolding. Better tools for formal verification, clearer norms for what counts as authorship, faster peer review that doesn't buckle under the new pace. Because the machines aren't going to slow down and wait for mathematics to catch up. The only real question left is whether the field's institutions can move fast enough to stay the ones deciding what's actually true. If this is the kind of story you want more of, verified, sourced, no fabricated hype, that's exactly what this channel is built around. Subscribe, and I'll keep tracking every one of these as they land. See task progress for longer tasks. A frontier neues summer script.md. Connectors, web search.